Hey there. Today I'm going to talk about Euler's number. And this is a number that shows up in advanced mathematics. It shows up in the natural world. So it's an interesting number to talk about. And it was, I guess, discovered, you might say, by this guy named Euler. And I've written over here because to me it's not obvious. It's pronounced like Euler, but it's spelled like Euler, or at least that's how I would want to say it. So that's my first little tidbit here. And I've written the first few digits of it, but like I said, it's an irrational number. So you can't ever write it as a fraction, and it never ends. You can never really write the whole number. You just can approximate it. So this is the approximate value of that number. I've written it out to 5 decimal places, but it just goes on and on forever like pi does, basically. Okay, so where does this number show up? Well, one of the first examples you might hear about is in compound interest. So that'll be my first example here, is in compound interest. And if you're not familiar with compound interest, then maybe you can learn a wee bit about it right now. But the formula for compound interest is A equals, and I'm going to explain what all the letters stand for here in a minute, but 1 plus r over n to the t, to the n times t. Okay, so this is the formula for compound interest. And basically when you're learning about this, you kind of just have to memorize that. You can derive it, but it might be a little tough. So, and then I'm just going to use the most simple version humanly possible, I guess you'd say. And I'm going to set, so like I said, I did tell you I was going to explain these, so let me do that first. I'm going to use the simplest number, which is 1, okay? But P is for principal, and that's the amount of money that you start out with, because compound interest is how much money you're going to end up owing, right? So P is my principal. I started out with $1, okay? A is going to be the amount that results, okay? If that's not obvious, the amount you end up with. All right, so then the next variable is R, and that is your interest rate, whatever the bank is going to give you. And so for this particular example, again, I'm going to use the simplest, which is going to be 100%, and which is the same as 1, right? 100% is 100 over 100, which is 1. And N is the number of times interest gets compounded per year, if I can say that correctly. It's the number of times you get compounded, your interest gets compounded per year. Oops, go away, we didn't want you. And then N is how many, I'm sorry, T is how many years, but I'm just going to use T is the time, and that is just going to be 1 year. All right, so I put in 1 for everything that I can. The number that's going to change is my N, how many times it gets compounded. That's going to be the interesting variable that changes, okay? And as it changes, you will see what happens. All right, so if I were to simplify all of this, I could write it as 1 plus 1 over n to the n. Okay, I hope that makes sense, because I've replaced some of these numbers with 1s, and the P went away because it's a 1, so we don't need to write it. The T went away because it's a 1, and we don't need to write it. So this is the simplest form of this formula that you could ever have, basically. All right, so what happens, when does E show up, right? Because that's what we're talking about. And what happens is as N gets larger, this number gets closer and closer to E. So if you were to put in an N of a small number, you would get something close to E. Okay, remember E is 2.718, 28, et cetera, et cetera. So let's say you might get 2.8 or something. Okay, and as N gets bigger and bigger and bigger, you're going to get a number that is closer and closer and closer to E. All right, so if you put in an N of 1,000,000, your number is going to be even closer to E. So basically, and we would write it's the limit. The limit as N approaches infinity is E. Okay, so if you start putting in bigger and bigger n's, you're going to end up closer and closer to e. And that's just kind of a magical thing that happens with compound interest. So that's my first example, and I didn't put in any real numbers other than just to show you the most simple form, and I hope that makes sense to you. Okay, so let's go on with another example, because I want to show you a few things. Okay, so that is one way that n shows up. This is the second way, and there's many of them. Okay, I'm just going over a few. This is probability. And this is a crazy thing. This is a really crazy thing. So if I were to make a little table here, and I put in the number of sides, and I'm rolling a die here. So the number of sides of my die, the number of rolls, and pardon my horrendous handwriting, and then the chance, and I wish that I could write nicely. I'm trying. Chance of not rolling a particular number. In this case, let's say the chance of not rolling a 1, right? Because every sided die is going to have a 1. So the chance of not rolling a 1, so I'm going to make this little table. Okay, and I'm just going to use a few little numbers. So you put in a 4-sided die, you roll it 4 times. The chance of not rolling a 1, and I'm just copying this off of some information that I got, okay, is going to be 0.3164, let's say, and some may go on forever. All right, and then 6, it's going to be 0.3349, and so on and so on. So the more die I add, the closer and closer, and this is kind of like my compound interest, it gets closer and closer, not to e, but to 1 over e. 1 over e, which is approximately 0.3679. So if I have like a 1,000,000-sided die, which would be crazy, right? That's theoretical if we couldn't even make such a thing. So we would expect if we rolled it 1,000,000 times, the chance of not rolling a 1 would be something close to 0.3679, which is 1 over e. Okay, so that's another example of Euler's number showing up. Okay, last one. This is number 3, and this is also not straight e, but it is a function called y equals e to the x. Okay, and that just means that number e raised to the power of x. So you know how you have your xy coordinate. So this is basically a function where y is dependent upon x, and you can add, you know, you can put in an x of 1 and an x of 2 and so on, and then you get a matching y value, right? So e to the 1 is going to be, you know, e, and then e to the 2 is going to be e squared, and so on. So you'd be able to plot this on a coordinate plane. But if you were to plot it as in polar coordinates, you're going to end up with something very interesting. And I'm drawing it very roughly. Please don't be mad at me because it's nothing close to perfect. But you're going to end up with something that looks like this. And like I say, that's a very rough drawing, but this is called the logarithmic spiral. And it's not straight e to the x. It's got some other stuff in there. So when I said e to the x, I was oversimplifying, but the idea is still legit, that you're going to have some other stuff involved, not just this, okay? You're going to have some funky other numbers that I didn't actually make a note of because it's beyond the scope of what I want to talk about. I'm just talking about a very brief and very simple overview of Euler's number. So you're going to end up with a logarithmic spiral, and you're going to look at this and you're going to say, this reminds me of a lot of things in nature, right? When I think of nature, I think of shells and flowers and things of that sort, and that's exactly what this spiral is going to remind us of, right? It looks a bit like a rose, or it could be a shell. So this has just been a quick and brief overview of Euler's number and some places where it shows up. I hope this was interesting for you, and thanks for listening.